Hello everyone, my name is Jan, and together with John we'll talk about notebooks and graphics in the Wolfram Cloud today. So most of you probably know the notebook interface of Desktop Mathematica, where you edit your notebooks, you do your computations, you interact with dynamic content. And our mission is to bring that experience to the web. So the idea is that you have that full-blown notebook interface in a web browser without installing any plugin or installing any local software. You get that same sort of experience right in your web browser. And that's not only interesting because it allows you to edit stuff in the cloud in your web browser, but also because it allows you to deploy things into the cloud so that you can share your content, whether you create it on desktop or in the cloud, with other people anywhere. What you see here is actually such a cloud notebook. So I'm in a web browser. It's just running on my local machine so that we don't have any issues with network. But it's using the same kind of cloud notebook technology to render this notebook and these slides. So let's dive into this and see what we can do here in case you've not seen it yet. So this is the usual notebook interface where you can type stuff. You press Shift Enter to evaluate things. You get back a result. You can create different kinds of cells like subsections and text cells, of course. And in the cloud, I mean in this case on my local machine, there is a regular Mathematica kernel running, so you can do all sorts of things that you can do with Mathematica, like do math, for instance. And if you integrate such a thing, you get back an output. It's not looking completely perfect yet, but I think we're getting better and better. And so this is actually rendered right in the browser using the JavaScript front end. It's not a static image either, so if you go and resize the browser page, you will see that this line wraps pretty nicely without fetching a new image or anything. So that's all sorts of output you can get. And of course, notebooks are also about dynamic user interfaces. So a very simple example, you can have a button in your notebook that when you click it, prints something into your notebook. Just some very basic examples, and John will talk more about graphics in notebooks.
Okay. So yeah, I'm the primary person who deals with graphics in the cloud. It's a lot of work, but we support graphics very, very well in the cloud. So here I'm starting with our 2D graphics. And again, it's important to note this is not a bitmap or a raster. In this case, the implementation here is SVG. So we can select it, we can resize it. It's pretty cool, at least for me. And a lot of work goes into this. And again, here's a different example. I'm going to show off the actual tooltip feature if I can mouse over this kind of correctly. So it's kind of small, you can't see that, but you mouse over the point on this graph plot, and we have a little mouse over. And again, that's natively rendered in the browser. Okay. And again, this one is also resizable. So here again is another example for that of what we're supporting. Again, it's generalized at the box level, so it's not anything spectacular. Any graphics will work. Okay. Similarly, what about 3D? Well, again, we've done a very good job to support this. This is interactive. Okay, you have rotation, you can zoom, and you can pan. Okay, this is using WebGL. And again, a lot of work went into supporting this correctly at the box level, so it just works for other types of things that typeset as graphics 3D. So here's a case with parametric plot 3D with the mesh option. Again, it's rotatable. And here, again, just kind of something showing off the lighting that is supported. in this case on the sphere. And again, because of how it's implemented, it just works with all things that end up typesetting as graphics 3D. In this case, chemical data, molecular plot of caffeine. So it needs to download some stuff to grab that model. And there we go. And again, interactive. And I just have one more example here. Okay. And then I'll turn it back over to Jan. He's going to talk about some dynamic.
Mm-hmm. So besides graphics, I think that's another fundamental building block of notebooks, is dynamic feature. At the most fundamental level, what you have is some area on the screen that says this is bound to some kernel variable. So if you have dynamic of S and later in some other evaluation assign a value to S, that part of the screen will update dynamically. That's been working for a while. I think what we added support for rather recently is also dynamic option values. So here we have some style. The font size is a static value, but the font color is dynamically bound to a variable C. Now, as soon as I update the value of C, the text color changes dynamically. And with these fundamental building blocks, you can build all sorts of dynamic interfaces, especially when you link things together. So I can create another control that's also bound to this variable C. And as soon as I click that color setter and choose a different color, you will see that the text color changes immediately. So yeah, that's something that allows you to build interesting interfaces. Now, what we also changed rather recently is support for continuous action. So not too long ago, you only got an update from a slider when you clicked at a certain point. But what makes it more interesting, of course, is if you can drag the slider and get feedback immediately. And that's what we just implemented. Now, what you'll also see here is this little ghost slider, as we call it. And that's an indicator that shows you where the current kernel value is, because there's always going to be some latency between the client and the server. I mean, they have to communicate over the internet. So in order to give some feedback what's going on in the background, we show this little ghost slider. And that's basically reflecting the number you also see on the right. Another update we're just making to the dynamic functionality is support for preemptive evaluations. That's important when you have a notebook with some long-running evaluations while you're also interacting with dynamic content. So, I mean, this is some artificially long delay. But at the same time, while this shift-enter evaluation is running, I can still drag this slider and get updates immediately. It's basically making a short interrupt to the kernel and getting an update for the dynamic right away. So that's some updates to the core dynamic functionality. Something that's very related to dynamic is dynamic module. It's maybe a bit hard to understand at first what it does. The main 2 points of dynamic module are that it persists variables in your notebook. So if you have some dynamic module variable that's bound to control, you change the variable, and then you close your notebook and open it again, it will persist. So it will have the same value even after opening the notebook again. And the second point is that, I mean, it's related, of course, is that these variables are sort of owned by the front end. So when some computation involves these dynamic module variables, in some cases it can skip going to the kernel to do the computation, but it can actually stay in the front end and do the evaluation there. And that's particularly interesting in the cloud, where the trip to the kernel might take even longer. So you might want to save some time by using a dynamic module. To demonstrate this, I have here a simple example where we have a graphics with an event handler, and as you mouse over it, it increments a counter that you see on the right. And it's sort of okay, but you can see sometimes there's quite of a lag, right? So I'm constantly moving my mouse. It's not updating continuously. Now the same thing we have here wrapped in a dynamic module. Again, we have some variable, but this time it's owned by the front end. So as I'm moving my mouse here, you can see it's updating much, much faster. And the reason, again, is that this increment operation here and also the assignment are purely happening in the JavaScript client, right, in your browser, without going back to the kernel. So we invested some development effort into implementing certain kernel features in the JavaScript client as well. Of course, by far not everything, but simple things that allow you to build certain dynamic interfaces do work. And one interesting thing that we built with this is zoomable graphics. I won't go into the details, but the idea is basically that, again, you have a dynamic module that keeps track of two positions. You click on some position, then you drag a rectangle and you let go of your mouse, and then it zooms into that area of the graphics. So yeah, there's a dynamic module, and then in the graphics you have this dynamic thing for the rectangle as you drag, and the plot range makes use of a dynamic option value. Now if we evaluate this and then decorate some plot with this zoomable wrapper, we get the plot as usual, but now I can click somewhere and drag the mouse around, and you see this rectangle being drawn. And this is now making use of that functionality I showed earlier. This is not going back to the kernel while I drag the mouse around. It's just staying on the client side. Otherwise, this would never be as responsive. And now as I let go somewhere, it zooms into that region. I'm going to repeat that. So you can zoom closer, and also included a reset button, so that resets it to the original plot range. Thank you. So I think the really cool aspect of this is that we basically provide the fundamental building blocks for you to build dynamic interfaces using the Wolfram language. That's a very interesting aspect. At the same time, of course, sometimes it's better to build things right into the system, to have native implementations of certain things in JavaScript, and that's what John is briefly going to talk about.
Okay. I'm glad you liked the zoomable plots there. It took quite a bit of work. It's tricky to get that to work correctly within graphics, the full dynamic capability of the front end. It's still something we're working on. But as John said, kind of interactive, so here you kind of built your own interactive graphic. And what we're working on the cloud side, which is great because it's a little bit easier for us to try and demo new features just from how it's built. It's a little harder to add those in the front end, but it's something we're working on the desktop team and in the cloud for kind of built-in interactive graphics. So I kind of have a pre-generated example here with a list plot, and with a little bit of setting of an option here in the method, we get a nice interactive drop line. Okay, much simpler than more complicated code that you saw on the previous slide. And again, another kind of similar example, not very super interesting, but something to kind of shut off here is highlighting points. So I purposely made the magnification pretty high here so you can see it. Again, it's kind of built-in interactivity. The next example here just does both. So we highlight the point and we draw some drop lines. And again, just to show you that this is kind of can be built-in capability, here's an example. We don't specify any options, and the default behavior is to draw a drop line and highlight the point. Okay, so that's something that we're working on the cloud side and also in the desktop moving forward. And again, as Jan said, the really cool part of getting some of these building blocks working in the cloud is that you can kind of see it all come together. One very good example of showing this off is Manipulate. So we've had Manipulate support in the cloud for some time, but initially it was a kind of a custom implementation. We didn't have the dynamic module or dynamic or continuous updating kind of supported yet, so it was more of a custom kind of built into our JavaScript front end. And while it did work, it wasn't very generalized. So we only had a very kind of small portion of manipulate supported. But thanks to all of the kind of building block level work we get, we're now supporting a box-based manipulate, and it works much, much nicer and more generally. So here again, we're updating. One of the new boxes that we've implemented is Animator in the cloud. So there you go. It's animating. And again, this comes from the low-level constructs that we built up. You should be applauding. This is very cool to get working in the cloud. So yeah, you can thank Ian for that up here in front. He did a lot of work for us. We work very closely with the front-end group, and they help us out a lot. So again, here's just some other manipulate examples to kind of show that this is just working more at the box-based level. Here we have the plot within. Again, very, very straightforward. A bit more complicated example. Here's our 3D graphic inside this. And if you had used the cloud earlier, you would have known that before this was only an image. Now it's the proper graphics that's embedded in there. So you can, if I can click correctly, you can rotate this with inside the manipulate and zoom and pan, etc. So again, that comes from supporting this at the box level, kind of from the low level up. Here's another example, just kind of showing off more of the controls. And the thing to notice here is we have 3 different graphics embedded within this manipulate. This is something that was not really possible in our previous implementation. It just works because, like I said, we supported the box level functions. And then here's another kind of example that I like, which kind of shows off some of the things we support in terms of like the drop-down controls and such. So again, that comes from building the building blocks, and we get a lot of things that just start to work and manipulate that previously didn't. So speaking of those types of controls and supporting other boxes, one very commonly used control is Locator or Locator pane. And this is something that I just added support for in the last few months by popular demand from somebody who I won't mention. So again, the very simplistic case, but it gets more interesting because it works with dynamic. So here we have 3 locators, and we're going to dynamically update the position, and it just works. Okay. With the low-level things that Jan talked about, we properly support dynamic module, it makes it much, much easier to implement the locator pane. Again, I'll just give another few examples. This one is pretty neat. We're tying a slider to the locator. So here we go. And just to show you it's not just one way. And then another one here. Sorry, missed this one. Again, I have a polygon defined by some locator points, and we drag them around. And it gets updated. So note, it's not quite as snappy as the desktop front end, but again, something that we're looking to improve. And my last example, again, kind of similar, but just a different type of plot that we get kind of for free because everything is working together at the box level. So again, another thing that seems kind of simple, which is sound, uses a lot of these kind of things we talked about together in the presentation. This also now works natively in the web. Hopefully you can hear this. Probably not way in the back, but if you, this now works in a web browser, playing your audio file. So again, one of the things we kind of get from all the box level support kind of coming in together. I'll turn it back over to Jan to talk about something a bit more interesting than rendering of graphics, deploying notebooks in the cloud.
At all. Yeah, so the question is, of course, once you have your dynamic interfaces defined somewhere, how do you get them into the cloud for other people to look at them? And the answer is simply cloud deploy. So when we take a manipulate like this, all you have to do is apply the function cloud deploy, and what you get back is a cloud object that has a URL. And when you go to that URL, again, this is now opening just a different browser tab, it will give you that manipulate, of course, that's interactive. One thing to keep in mind, though, is permissions. So the reason this just worked is because I'm authenticated in this browser session right now. So that's why I can see this object, even though it's private. And I can look at the permissions of that cloud object, and that tells me that only the owner of it can read, write, and execute this file. If you were to open this in a different browser where I'm not authenticated, so over there, you would get to a sign-in page. So this is now, again, a different browser, not authenticated. It asks me to authenticate. If you want to share cloud notebooks with others, you need to set different permissions. And the most straightforward one to share a notebook with everyone is to use public permissions. So if you cloud deploy with permissions goes to public, again, you get a notebook. Now this time, I can also open this in a different browser where I'm not authenticated, and I should be able to see the manipulate. Yep, and I can also interact with it. Now again, if you look at the permissions, it tells us that everyone has now read and interact permissions. There's a lot of granular permission settings. You can look it up in the documentation for permissions. I should note that not all of them apply to the deployed view of notebooks. So everything that's related to editing notebooks, that's only allowed for people that are using the Wolfram programming cloud as a product. So in a deployed view where the viewer does not have a subscription to the cloud, they won't be able to edit yet, at least. That's something we still have to figure out. But reading a notebook, I mean, looking at the notebook and interacting with it, that always works fine. So much about cloud deploy. One thing that we also just noticed actually is that due to this large piece of JavaScript and all the resources that have to be loaded in order to render notebooks, it can take quite a while for notebooks to render, especially for the first time. And we wanted to address that somehow. So what we came up with just now is this, what we call HTML cache. The idea is that when you edit and also close a notebook, we generate a static piece of HTML that represents the same piece of content, but it allows the browser to render this piece of HTML immediately. That really goes quite fast, while in the background it still loads the JavaScript and all the other resources that are necessary to render a notebook. So if you look at this, I'll just make this other deployment that now has an artificial delay in it. So to manipulate, it will wait for 3 seconds and then display something. The first time, again, we see that you get this spinner and it takes a while to come up. But now when I visit the same notebook again, which in this case I can just do by refreshing the page, you'll see that it always stays visible. So now I'm already on the new page, sort of. I still get that spinner on the right that's indicating that something is still loading, but at least I was able to see the content immediately. So you can see something immediately. It just takes a little while to get interactive. That's the whole idea of these HTML caches. We're still working on that quite a bit. So currently, the way it works is that the browser is sending this HTML cache to the server when you edit the notebook. The way we're changing is that we'll generate the cache on the server side. That gives us more flexibility to account for different devices, different screen sizes, and so on. So there will be more improvements in that direction. And then notebooks should really render quite fast when anyone opens them. Another thing that I want to briefly talk about is how you can embed notebooks in websites. So, of course, notebooks are nice, and ideally maybe the whole internet would be notebooks, but of course that's never going to be the case. We always have some pieces of HTML, some pieces of JavaScript, and you might want these things to interact with each other. What I briefly want to demo here is if you have some HTML file like this one here, and you can actually edit HTML files in the Wolfram Cloud as well. So you have this file, it just has a simple iframe in it that embeds another notebook. And then I added some JavaScript code that sort of talks to that notebook. I'm just going to show this. So we now open that HTML file. And these are basically native JavaScript controls that any web developer could write. But down here we have a regular notebook that makes use of all the capabilities in the Wolfram language. Now I can do things like insert a new cell here that evaluates something. And since this notebook down here uses a dynamic, it immediately updates too. I can also use this button to evaluate some expression without inserting a cell, or I added this little animate button that basically continuously evaluates an expression to increment the T counter. So now you'll see this thing moving down there. It's very similar to what you could also achieve with Animator Box, but this time it's demonstrating that you can get this sort of control in JavaScript if you care about that. So we're still working on this API. It has quite a lot of methods already. But what would be really interesting for us is if you have any ideas what you want to do with this sort of thing, maybe we could talk about that and take that into account as we design and develop this API. And that already brings us to the end pretty much. Just some outlook, what's going on and what we will be working on. Of course, we're constantly working on improving support for notebook and box rendering. I think we already came a pretty long way, but there's always more work to do. And there will probably always be some limitations that you just won't be able to do in the cloud. And we have some efforts to document those limitations. I think that's something that we still have to do so that you know what you can expect to work and what won't work too soon. But we're working on that. And then more longer term things are still a more advanced editor that allows you to do two-dimensional editing, like grids, as we saw before, or things like superscripts and so on. That's something that's a pretty big challenge, but I think eventually we'll get there. And another thing we really want to get to is live collaboration on cloud notebooks. The idea is that 2 or more people can work on the same notebook at the same time, and you see changes immediately. I think we have a pretty strong framework to do that now, but it's still going to be quite a bit of work to actually implement that. Yeah, that's basically what we wanted to say. There's some related talks coming up about cloud and also using dynamic interfaces that might be interesting. And I think we have some time for questions now. Thank you.